Hello everyone. Today we're doing solutions of system of equations. I'm gonna be taught by a math teacher, and she's gonna be teaching me how to solve or understand this type of questions, which I have no idea at the moment, but I believe that after she finished explaining and teaching me and me asking some questions to clarify this stuff, I'll be a better mathematician.
Yeah.
I'll be a better mathematician. So I'm really looking forward to learn this stuff from an amazing teacher. Let's go.
All right, so we're looking at solutions of systems of equations. So we've got two things to discuss. What's a system of equation? How's it work? And two, what's a solution? How's it work? So we've got two of those things in this problem. The fact that it gives us a solution makes it more options on how to solve it. So I want you to tell me kind of what you think a system of equations, or just a system in general, based on your life experience, what that means to you.
Well, a system is like a set of rules that you have to follow. That's what I think is as a system, or something that is designed to work for you.
Yeah, and if you think about it, a system typically has more than one thing working together to the same goal.
Yeah.
So that's kind of the thing that makes a system of equation apply to a system, and just, and how we typically talk about it in life. You'll sometimes see these curly braces, or just one curly brace at the height of the equations in a system. So I just kind of want to show you that notation. So the system of equation is right here, these two equations. And a system of equations in math is two or more equations, so more than one thing working together, that have the same variables. So can you tell me what the variables are in these equations?
The variables are the letters, correct?
Yep.
So here we got y and x.
So the variables are x and y. All right. And we got two or more, so it's a system. So basically, these are two equations that they work together. So if you put them on the same graph, it would help you look at them.
Yep.
There may be two situations that you're going to compare. Like, let's say you're looking at the height of two different plants that have the same species, and you want to figure out when they're the same height. Well, you could use a system of equations to figure that out. Maybe x is your time and y is your height.
How about we graph that the time and the length?
Sure.
So I can see that first.
So we will graph these two lines, and then we can kind of see what they look like. Now, this is not going to be the best situation for plant, because it's decreasing in height because of this negative right here. Unless, of course, your plant was dying, which I guess you could look at it that way too. So
yeah, you can think about it like that.
So let's look at...
What about we first plug the coordinate planes 3 and 7?
3 and 7? Sure. So
I can see where we are.
So I like that you said the coordinate. The coordinate point is what this would be.
All right.
It is a point on the graph, 3, 7. So let's go ahead and plot that. We'll do 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7. So we're plotting this point. Do you know what this point potentially means?
That is one of those. Both of them should meet at that point, right?
Yes.
Because those are linear equations, correct?
Yes, they're linear equations.
There should be a line, and both lines should meet at that point. Am I correct?
So if your answer is going to be yes, then this 3, 7 is the meeting place of these two lines. Perfectly said there. So that's what a solution is. That's all it is. It's the meeting point. It's if you're looking at a graph, it's where the two functions intersect. And there could be more than one solution, but for lines, it's one. So let's think about this 3, 7. So this is kind of us visualizing that point. And do you want to graph these lines?
Yeah, let's do it.
Okay. So both these lines are in...
Now what is the form that they're in right now?
That's exactly what I was going to say. That's so cool to think about that.
Yeah.
So this is in the y equals mx plus b form, which is called slope-intercept, because m is the slope and b is the y-intercept.
Gotcha. Yeah, because I know there's at least two more different forms that you can have a linear equation set as, correct?
Yes.
All right.
There's two other main ones.
This is the one that I know of. With the other ones, I know you have to like rearrange some variables around to make it work.
Right. This is the most starting out kind of form you probably see, and it's probably in most people's opinion the easiest one to look at if you're going to graph it.
All right.
So if we look at B, your y-intercept, what's it mean when you intercept something?
When they both touch at the same place at the same time.
Yeah, or like if you think about interception, like interception in sports. Okay, I'm gonna intercept the ball. Well, I'm gonna
get in the way of them.
I'm gonna get in the way. I'm gonna touch the ball. I'm gonna meet it.
So the y-intercept is where the y will intercept, which is the y axis.
Yeah, this y-axis. I'll put a y there, and here's our x-axis. So this point B, let's look at this first equation. We have this -5 here.
-5.
So then we're going to have 1, 2, 3, 4, 5. Here, -5 is where this equation or this function crosses the y-axis. And our slope is the number in front of the x, which is, in this case, what?
-4.
-4. So that means slope, remember, is rise over run, or the change in y over the change in x. So for this case, it's -4. And if you want to think about it as the run, you could think about it as 1, because if you divide something by 1, it stays the same.
Yep.
So we're going to go down 4 over 1. Another way to think about this is go up 4, left 1. So either way, these are equal. Right. So let's go up 4, left 1 because of how our graph's made. Yep. I don't want to have to make a lower graph.
Yeah.
So if we start this point...
Is that what you did? Do you inverse the rise over the run?
Yeah, I put the negative on the bottom, which, if you think about it, what's -4 divided by 1?
-4.
-4. And what's 4 divided by -1?
4.
-4, right?
Oh, -4.
Either way, it's -4, which is what our slope is. So this is just a different way to think about it.
Oh, yeah, because the -1 is it has a negative under it.
Yes.
All right, go for it then.
So I'm going to make a -1 here, and if we go up 4...
Here, let's erase this.
Yeah, let's erase some so we can do our graph here. Okay. So if we go up 4... 1, 2, 3, 4, and go over 1, that gives us another point. And if we connect those, you only need 2 points to draw a line. Just look at your arm. Make it straight. Put your elbow down on the table. Now, can't you move your forearm wherever you want? So it's not like a defined line yet. But if you touch your other hand, you've defined another point, you can't move anymore. So you only need 2 points to define a line. So once you've got that slope made after like 1 point, then you made a line. And you have to remember, you got to start at your y-intercept. All right, so we see this line. Now, if you think about it, is there any way that this line is going to touch this point?
No.
There's not, because it's going to go forever in that direction and this direction.
So you already know this is not going to be a solution.
Right, you already know it's going to be a no.
All right.
So if you're thinking about it graphically, you can already be done. Because what you want is the point where if 3, 7 is the solution, it's got to work for both the equations. It's got to be on both the lines at the same time.
All right, so let's check.
Let's say no. Here we go.
Perfect. It seems like I understand this better now.
Good. All right, so that was solutions to systems of equations. So tune in next time. Learn something different.